Okay, let's talk about more trig. We're going to start off with, these are called trig identities. Identities help you simplify expressions. That's the idea. I'm going to start, I know we're talking about reciprocal trig, but I'm going to start with the idea of complementary identity. Okay, this will be best illustrated through an example. Let's call this alpha. So let's find sine theta and cosine theta. And then let's find sine of alpha and then cosine of alpha. Okay, sine of theta first. I know I have opposite adjacent hypotenuse. Sine SOHCAHTOA. Might as well just write that one down again. Sine is going to be opposite over hypotenuse, so sine is 4/5. Cosine is adjacent over hypotenuse is 3/5. Well, now I go from alpha, just write that in green, so we can, basically all that does is switch opposite and adjacent. So sine from alpha is going to be 3/5, and cosine is going to be 4/5. Oh, what do you notice there? Notice that sine of theta and cosine theta are the same. Sine of alpha and cosine of alpha. Sorry, sine theta and cosine alpha are the same. Cosine theta and sine alpha are the same. This is the idea of, we have some equivalent values for sine and cosine, and what do we know about alpha and theta? Their relationship is that those two angles add to 90 degrees, because all triangle interior angles have to add to 180. So since we already have a 90-degree angle, those two have to add to 90. And so what you're seeing here, this complementary identity, complementary meaning add to 90 degrees, is that sine of theta is going to equal cosine of 90 minus theta, or cosine theta is going to equal the sine of 90 minus theta. Basically, translation, sine of one angle in a triangle is going to be the same as the cosine of the other. And so, for examples of what I would ask you to do, instructions on your homework are going to say find the equivalent sine or cosine. And so, let's say I give you cosine of 20 degrees. To find the equivalent, I've given cosine, so I want to find the equivalent sine. Well, I need to make sure cosine of 20 is going to be sine of 90 minus 20, which is going to be sine of 70. And that's it. I don't need you to show that work, but I just figured for the first example, might as well show the work. So let's go sine of 36. All right, well, I've been given sine, so let's give the equivalent cosine. And now I do 90 minus 36, and I get 54. Great. Moving on. All right, let's talk about reciprocals. And of course, through an example. All right. Actually, you know what? Before we get there, let's talk about tangent. take back my song, I'm sorry. Tangent identity. There you go. There's a new song for you. All right, here's what we're going to look at. Let's say I have a graph, and I'm going to put a coordinate on this graph. And I'm going to create a right triangle from that. Here's going to be my angle, and I'm going to say that the hypotenuse is a length of 1. Well, with this being a coordinate on the graph, we are going to label these side lengths, and the horizontal distance, mind you, this is the coordinate x, y, which means the horizontal distance to the coordinate is x, and the vertical distance to the coordinate is y. With this diagram in mind, of a triangle with hypotenuse 1, sides being x and y, let's just take a moment and identify sine of theta, and then cosine of theta, and then tangent of theta. Alright, if I look at sine of theta, here's opposite, adjacent, hypotenuse. Sine of theta, I know, is going to be y over 1, which is the same as y. So sine of theta would be your y coordinate in this situation. Cosine of theta is going to be x over 1, which equals x. Okay? And tangent of theta is going to be y over x. And at this point, you're like, where the heck is this going? Well, because of COVID, we had to skip a day of kind of really tying in what this would be useful for. I can tell you right now, this is going to be useful for physics. It'll also come in handy for next year in Sec 3. But here's what I really want you to know from this. If tangent theta is y over x, here's y. Here's x. So tangent is actually equal to sine over cosine. And that is an identity. And so we could see this happen even just like in a triangle. Do our favorite 3, 4, 5. I can take sine theta, labeling my sides. Sine theta is going to be 3 over 5. Cosine theta is going to be 4 over 5. Tangent theta is going to be 3 over 4. Well, if I look at sine divided by cosine, that is 3/5 divided by 4/5. Anytime we're dividing fractions, ours is not to reason by, ours is not to reason why, but to invert and multiply, meaning to divide these two fractions, I'm going to keep, I think some of you have heard it as keep, change, flip. Keep the first one, change it to multiplication, and then flip the second fraction. Look at that, 3/4. That was tangent. Cool. So that's a tangent identity. This is going to be a big one that I want you to remember. I don't necessarily need you to remember this example we did, but I do want you to remember that tangent is sine over cosine. You're like, great, why do I care? We're going to get there really soon, I promise. Now we get to reciprocals. Okay. Here's what we got. We have sine, cosine, tangent. Great. Good ratios. There are other ratios. There are 3 other ratios that exist, and they are called the reciprocal trig identities. Okay, let's think about the word reciprocal. Reciprocal means that I'm going to flip a fraction. So here's what you need to know. We have sine, we have cosine, we have tangent. Well, we also have cosecant, which is abbreviated as CSC of theta. And cosecant is the reciprocal of sine. You'd think it would be cosine, but it's not, and I can't tell you why. I don't know. We'll wait on that. We also have secant, which is written shorthand by SEC. Secant is the reciprocal of cosine. And here's one that makes sense. Cotangent, written shorthand as cot, which is the reciprocal of tangent. Okay. Well, let's take a look at, well, reciprocal of tangent, if you remember from, just a little bit ago, tangent is sine over cosine, which means I could take the reciprocal of that and get cosine theta over sine theta. All right. We're going to look at this just from a triangle perspective first. Okay, so just from a triangle perspective, I can label opposite, adjacent, hypotenuse. And I can see that sine of theta is going to be 24 over 25. That was my opposite over hypotenuse. So if I want to find, well, let's just finish. Cosine theta is going to be 7 over 25, and tangent theta is 24 over 7. Once again, that's from SOHCAHTOA. Well, if I want the reciprocal identities, cosecant is the reciprocal of sine, meaning since sine is 24 over 25, cosecant is 25 over 24, because I just take the reciprocals. If I want to find secant, well, secant is the reciprocal of cosine. Since cosine was 7 over 25, the secant is 25 over 7. Tangent is 24 over 7, which means cotangent is going to be 7 over 24. And so that's all that's taking from a triangle perspective. I'm just finding reciprocals. Not a super big deal. Just remember also missing sides in a right triangle. Are found using Pythagorean theorem. Just as an FYI. Okay, that's basic reciprocal identities. Where are we really going today? I'm about to show you. And make sure my microphone's on real quick. Thank goodness. All right. I'm actually going to start a different video for this.